The next thing we're going to look at is if you have a formula for a function, y equals f of x, how do you find a formula for the inverse function? Okay? And I'll say, depending on the function, it's not always possible because you have to be able to solve an equation, but for most of our algebraic functions that we look at, it is possible. We like function notation, it's really useful, but when we're finding the inverse, we're going to be manipulating both sides of the equation, and it's going to get confusing if we have the of x floating around with the x. So instead of writing f of x, if our function is presented that way, we're going to replace it with y. And then you can do steps 2 and 3 in either order, but I think it's probably a better idea to go ahead at the beginning and swap the letters. Okay, we're going to swap x and y and then solve for y. What we're doing is finding the function that does exactly the opposite with x and y. So we could take our function and solve it for x, that way our inputs are y and our outputs are x, but in algebra, by convention, we like to label the inputs with x and the outputs with y, so we also swap the letters. And you could do that at the end, but sometimes we forget, so it's probably better to go ahead and do it at the beginning. We're going to swap the labels, that way we're literally reversing the role of x and y, and then we solve for y. And the result would be our inverse, and we could use inverse notation if we want to. So step 3, you got to solve the equation. That's where the difficulty comes in, possibly. Depending on the function is going to determine how difficult it is to solve that equation. And again, some equations can't algebraically be solved, but we're going to look at examples where we can. We're going to start with a linear function, the simplest type of functions we work with. So find the inverse of f of x equals 4x plus 7. Okay? So if we're following our steps there and take it out of function notation, we've got y equals 4x plus 7. We're going to go ahead and reverse the role of x and y here, so let's swap the letters x and y, and then we're going to solve for y, which is pretty easy for a linear function, just 2 steps. Subtract 7 from both sides, we get x minus 7 is 4y. Divide both sides by 4, we get that y is x minus 7 divided by 4. You could split that if you wanted into 1/4 x minus 7/4, but the goal was just to solve for y, so I'm going to leave it as the fraction there. And so if we want to use inverse notation, there we go. It's x minus 7 divided by 4. That's the inverse. So f inverse of x is x minus 7 divided by 4. And again, the notation, the f to the negative 1, we would read that as f inverse, so the inverse function of f. Okay, let's do a couple more. This one algebraically is probably one of the more challenging ones that we tackle at this level. It's not that bad, it's just there's a few steps that, depending on how much algebra you've done, you might not think of the first time, but anytime you see one that looks like this, it's going to be basically the same steps. So we've got our function. If we take it out of function notation, y is 2x minus 4 divided by x plus 3. We would call this a rational function, where the numerator and denominator are both polynomials. In this specific example, they're both linear functions. We have a fraction of linear functions. So anytime you have that, here's basically your steps. We need to swap x and y. Okay, at the beginning, we're going to reverse the role of x and y, so we swap the letters. And then we need to solve for y, which is a little more complicated this time because of the fraction. But when you have a fraction, the first thing you usually want to do is get rid of the fractions, clear the denominators. I'm going to multiply both sides by y plus 3. If I do that, I'll get x times y plus 3 on the left, and the denominator would cancel, and we'd just get 2y minus 4 on the right. Then I'm going to distribute. So do x times both parts inside the parentheses. We get x times y plus x times 3, or 3x, is equal to 2y minus 4. Okay. We're trying to solve for y, so we're going to move all those to one side, and I did it. You can do this probably in one step, but I went ahead and did it one at a time. I'm going to subtract 2y from both sides. So we get xy minus 2y plus 3x is equal to negative 4. And then the 3x term doesn't have a y, so I'm going to move that to the other side, subtract 3x from both sides, and we get xy minus 2y is equal to negative 3x minus 4. Okay? So let me summarize so far. We swapped our x and y, and then we needed to solve for y, so I multiplied both sides by the denominator. There's your big step to clear the fraction. Distribute, and then use algebra to move everything with y to one side, everything else to the other side. And then kind of the key that, say, kind of stumps students a lot of times the first time you see one of these, you have to factor here. You have to use the distributive property in reverse and factor y out. Since we have two y's there, we have xy minus 2y. Our distributive property in reverse there, we can factor the y out and get x minus 2 times y. And if you went backwards there, it's the distributive property, x times y minus 2 times y. So that's kind of the key. We're going to multiply by the denominator, distribute, move all the things with y to one side and factor y out. And then you can just divide. It's y times this entire term, so I can divide both sides by x minus 2. And there we go. We get y is negative 3x minus 4, all divided by x minus 2. That's our inverse. If we want to use the inverse function notation, f inverse of x will be negative 3x minus 4 divided by x minus 2. Okay, let's do one more. I can't possibly do examples of all the types of functions you might ever see because there's infinitely many, right? But I'm trying to cover some of the basics that you run into. So we had a linear function, a fraction, here's a power function. We solve power functions by taking roots. Okay? So we've got y is x minus 4, that quantity raised to the 7th. You have to undo orders of operations, in the backwards order here. I can't handle the 4 until we take care of the 7 there, so I need to take the 7th root of both sides. Well, first I need to swap the letters, right? I always forget to say that. I need to swap the letters x and y there. Take the 7th root of both sides. We get the 7th root of x is equal to, if I take the 7th root of the 7th power, those are inverses of each other. They cancel out and I get y minus 4. And then add 4 to both sides and we have our result. Y is the 7th root of x plus 4. Or in inverse function notation, f inverse of x is the 7th root of x plus 4. So those are some examples. Again, the basic steps, go ahead and swap the letters so that we don't forget at the end here. In the end, we want to write a function of x, an inverse function of x. So we swap the role of x and y by swapping the letters and then solve for y. Okay? And then in the end, if we want, we can call it f inverse of x.